This is Project 2 for Team 09 by Angela Steinmetz, Shannon Riegle, Kevin Grimes, and Ashley Birkhimer. For Project 2, we use various techniques to induce image processing upon input images in PNG form. The steps of this image processing are edge blur and noise reduction, edge enhancement, and then finally edge thresholding. The project motivation and engineering applications are civil engineering, road repair, such as potholes, electrical engineering, analog and digital signal processing, biomedical engineering, tissue and disease monitoring through image techniques, and agricultural engineering, crop and pest management.
We determined that we needed 4 functions in order to complete the overall program for our project. We first used a function to convert the image to grayscale. From there, we performed edge blurring and noise with a new function. And from there, another function performed edge enhancement. And from there, another function performed thresholding on the edges. We did use a input function at the beginning so the user could input their own image and also to create error messages if this input was not a PNG file. So after going through the input and then all 4 of these functions, the output was the finished product, which was an edited image. The first function of our program was the grayscale function. With this function, we read in the image as a matrix of numbers. Then we used the weights for red, green, and blue in each pixel and multiplied those colors by these weights to create our grayscale image, which is Y in this equation. There were 2 options for the weights you could use. I chose to use the 709 standard because the 601 standard, the other option, is typically used for video color images. I then used np ... which returns the dot product of the RBG weights and the 3-column matrices, which creates the grayscale. Then I saved this image to a new file. So overall, the grayscale function takes in a colored image and outputs a grayscale of the same image.
For edge blurring, we first created a function which used the NumPy library and various matrix calculations and edits. We used outer and inner loops to change the matrix representation of the photo. We then output the photo and save the new blurred image.
Edges can be defined as an abrupt change in the value of a pixel. Therefore, if we take the derivative of the pixel values across an image and locate any maxima, we should be able to see the edges quite clearly. Since a grayscale photo is represented by a 2D matrix, we must find the magnitude of the partial derivatives in both the x and the y direction. This is known as the Sobel operator. To do this in Python, we use a 3x3 moving window operation. First, we create a new matrix of the same size as the original image. The original image is then padded to prevent any index errors while performing the window operation. The moving window then undergoes element multiplication with both the x and y filters separately, and the sum of the elements for both matrices is found. These represent the partial derivatives in both the x direction and the y direction. Therefore, to find the corresponding pixel value for the enhanced photo, we can use Pythagorean's theorem. Note that this entire operation, called the Sobel operation, occurs on a single line in the edge enhancement function. The reason for this is that by avoiding intermediate variables, the process is slightly faster. In addition, by using NumPy functions multiply and sum, we should increase the speed slightly just by reducing the number of nested for loops used. After the moving window covers all of the pixels in the original image, the final image is divided by the maximum pixel value, so that the pixel values in the new image range from 0 to 1. This will make it easier for thresholding. The final image is then saved to the correct folder and then returned to the calling function.
The final step in image processing is to further define the edges by only displaying those above a certain threshold value as white or 255 and below a certain value as black or 0. By utilizing nested for loops, I was able to iterate through each number in the image and check to see if I should increase it to 255 and make it white or decrease the number to 0 and make it black. In order to have a small variety, as certain images can be overall lighter or darker, we went through this process 3 times with 3 different threshold numbers. Our lower threshold of 0.05 produced a darker image, our normal threshold of 0.15 produced a more normal image, and our higher threshold of 0.25 produced a lighter image. We then saved each of these photos and printed it to the console that the process was complete.
First, I'm going to show you that all of the Python files and the 3 images we are testing are saved in the same folder. We also have a file folder inside called Lena test image. As we open up the Spider console, open up our main program and run, it will ask us for the name of the image we want to detect edges for. Let us first start with Dark Knight Rises. I get an error because I did not specify that I wanted a .png image. So now let's try Dark Knight Rise.png instead of Dark Knight Rises. We get an error because Dark Knight Rise is not the name of the file. It is saved as Dark Knight Rises.png. Once we plug in Dark Knight Rises.png, which does exist in the folder, and run, we create a new folder called Dark Knight Rises. You will also notice that the console will give us feedback for each image produced. So we have created the grayscale, the Gaussian, and all of them. And in the plot, you can see that we have the final image produced. As we go back to our folder, we see that the Dark Knight Rises folder is new. This was not there before. And if we open it, we see all of the photos of the process contained. We have the original color image, the grayscale image, the Gaussian blur. You can see the Gaussian blur really good. Look at Bane's eyes, and you can see it was blurred. We have edge enhancement, and from there we have 3 threshold value images. I personally like the low threshold best. In addition, now let's test what happens if we run Lena, since Lena already has a folder in here. If we run the program again, this time using lena.png, hit enter, instead of saying created a new folder like it did up here, create a new folder, it says files to be saved. This is because the program recognizes that Lena test image already exists, and it is not going to create a new folder when it already exists. Now if we open up the Lena folder, we will see the original image, the grayscale. We can see all of the images. Here is the Gaussian, you've got your edge enhancement, and the 3 main photos. I like normal the best. Finally, let us test. You will notice that the final image we have in this folder is the Captain America JPEG. So if I run the program one last time, this time testing for CaptainAmerica.jpg, we get an error because we need a PNG file.
Reflecting on our project, there were a couple of improvements we could make. We could have used a list of comprehension instead of nested for loops, as it would cause the efficiency of the code to increase and make it a faster process. This would apply the best for the edge enhancement function, as that was our slowest function. Another improvement was in the threshold function, as we could have passed the threshold value as a parameter as opposed to copying and pasting the same nested for loop 3 times and manually changing the threshold values for each of them.